Hi, this is Gülçin Yıldırım Jelínek. I do product at Xata. Today we will talk about what's new in Postgres 18 with constraints. I read all the change log, so you don't need to go through it yourself. And the talk is for everyone who is interested in constraints and app development with Postgres and into also database internals. I hope you will enjoy it. Okay, let's dive in. What's new with constraints in Postgres 18? Today's agenda looks like this. We will mainly focus on temporal keys that is introduced recently. We will talk about how not null became a first class constraint. It's kind of promoted from being a flag in PG attribute to a full force constraint. We will talk about the new concept not enforced. We always had for a long time we had the not valid concept already, but not enforced is new. We will talk about that too. And there are some improvements to partition tables in with the constraints, so we'll go through that as well. Okay, so let's start with the basic question, basically, like what is a constraint? When you define a table or a column, you can attach rules to them to check or enforce something. So this is important for keeping the data integrity in check and to avoid subtle data related bugs later on. So these rules are all called constraints, and data types itself also like restrict the kind of data a column can hold, but they are usually too general, too loose. So to be able to, let's say, you can't make a numeric data type to only exact positives, right? Or you can just ensure unique product keys or something like that with just normal data types. You have to have unique constraints. So this is why we have the constraints, and it is important to understand them early on when you are modeling the data, so that later on you don't need to go through the cleaning this data later on. You don't need to deal with it later on to prevent the bugs. So it is important to keep your data valid and consistent. Okay, so there is another way we can actually look how the constraints look like. They are they all have a matching entry in PG constraint catalog. So as you can see here in the table, constraint type is reflected with their name. So check and C, foreign key F, not null N, and so on. And before Postgres 18, you wouldn't see not null here. This is a new addition. So yeah, you can see them all here. So any constraint that you created, you can check them through the PG constraint catalog. And if you are new in Postgres, if you didn't know what catalog is, it is a system table. So Postgres keeps data about your own data internally. So let's say you have products, orders, users, those kind of tables. And Postgres keeps information about those tables, like how many columns there are, what type of indexes it has, what are the types of these columns, and so on. Specifically for constraints, we keep all this information related to constraints in PG constraint, but there are more of those, like PG class for the table, PG index for the something related to more specific indexes, although most of them are actually in the PG class, PG type for the types, and so on. So there are a lot of catalogs, and this is kind of Postgres' internal metadata. Okay, so this is was just like basic intro, and today's focal point is like what actually changed in Postgres 18. And I made a list that you shouldn't read now. We will go through all of it, and we will start with the top one about temporal keys, the newly introduced temporal keys to Postgres. And another like thing that I wanted to actually show with this slide is like how much work goes into Postgres in each release. These are all patches, and some of them are, for example, not null, is being developed, discussed since 2010, and basically now it is in Postgres 18. It took so many years, like 15 years, and it was actually being going to Postgres 17. This happens a lot, right? A patch can go to a targeted to went into a release, but it can't go as expected. There will be like maybe some issues, some more tests required, and all of those. So I just wanted to show here like how much effort goes into each release, and I wanted to thank everybody who developed this, who reviewed these patches, who tested it, who documented it, and all of it. Okay, so before, as I said, let's go. And before we start exactly what is a temporal key, I wanted to step back and see what makes a database actually temporal. So the What I colored in purple in the middle with the fourth and fifth criterion, these are what is just introduced, the temporal primary keys, unique keys, and the referential integrity we refer to basically temporal foreign keys. And we will talk mainly about those. But you can see there are most of the stuff already green marked because I marked what we have and we partially have the support or we kind of support all of it as green. What makes me very surprised that whenever I need or whenever I learn a new database concept, I came to Postgres and we either fully support everything, we have built-in support for those, or we have like parts of it, like building blocks of it to actually make this work. So this is the same, almost same scenario for the temporals too. Of course, the new additions, like the new temporal keys, closing the gap super quickly. But we already have some of the stuff, like we have the range types, the first criterion, we had operators, range operators that you can actually do the temporal queries. And what we lack is mainly is the first red marking in the third criterion is the system maintained transaction time. And we will talk about it. What's valid time? What's transaction time later? But yeah, we pretty much cover all of it. And this is amazing. I mean, I'm always surprised, and I want to share this with you too. So as I said, like the time is different for temporal databases because normally uh, for relational model, time is just time. But for temporal databases, it is a first class part of the data model. So there we have the ID in a way attached to always with a period. So that's what it makes it like a dimension and it's always there. So valid time and transaction time, there are two semantics here. The first time refers to, for example, I put an example here to make it easier to understand. What do I mean by like uh, when it is considered true in reality? So the fact it will be true for the business domain. That is how they actually explain it. Imagine there's an employee salary table. An employee's salary was like 5,000 from January to June 1st. And June 1st, the salary became 6,000. And there is like no upper bound limit there. So it's unbounded. And that is what we can see now. So this is the valid time. When we look at it, we can actually see for this employee in which period this information was correct. For example, if I'm querying for the March, I know that the salary was 5,000. So I keep this change with this value and when this happened. And what do I refer as transaction time, the system time that we lack of? And usually in the SQL standard, I think it's like system as of system time clause, which we don't support yet. So this is only if we had this already, we would know when this change happened. So imagine the case that an HR employee changed the salary on June 10, but this is effective from June 1st. So for us, then the transaction time when actual database knew this information will be June 10. So this is transaction time in the simpler terms. And usually in the relational model, we don't really have this like, when you update the salary, right? You lose all this information. Then you can't just say, what was the salary in March? When did it change? And was there any overlap or gap? That type of thing. But when you actually build it in the model, like the valid time model, then you actually can do like, okay, uh, what's happening? You can query the overlaps. You can actually stop the overlapping because then you could actually put the temporal keys that will allow you to do so. And that will be what we will talk later. And yeah, so I think this is like important because it's a different way of thinking, different way of modeling. And I'm happy that now we can actually do this in Postgres too. Okay, so this is something before I show you the exactly queries, how they look like, what I learned from Boris Novikov when he visited Prague in June 2025, a year ago. He said, and I quote it here, queries to a temporal database return facts that were, are, or will be actual at a time that may differ from current time. So this is a concept actually really defines what we talk, like each data row has an associated time period. This is how you define it. Periods are closed open, so they never overlap. and that's why we are doing this, non-overlapping clause. And for a period, for the foreign key, that's where all it comes from. So the relational model and over like the temporal model is in that way differs for the how they approach to time. When you have fully temporal model and you implement it, you can actually do proper point in time queries, and you can just do history of an item like event logs type of information, and you can just feed this output of one temporal query to another temporal query and so on. And also like the how modifying the data is also different. Like we normally, if you want to delete something, we delete it, and then here in the temporal model, what they do is like they only close the validity periods basically, and then it means that it's kind of deleted. So it is really nice. It is nice to think, nice to is an as an exercise. It's nice to like imagine how it will be done, because now it's much easier, more native. Before this could be done like uh, differently with exclusion constraints, with gist indexes, which I will also show. But now it's much easier. You can just have use like primary key, foreign key, DDL syntax, and it's amazing. And here I also wanted to show now like what do I mean. As you can see, like if I want to now query, as I said, like what was valid on March 15, this is the thing that I can just say, okay, give me like I wanna see for what happened in March 15. And then I can also now enforce this rule. Yes, an employee cannot have two salaries valid at the same time. And for that, I just created a primary key. And what's important is like the syntax without overlaps only comes to the last column. And this needs to be in a range type or multi-range type, the valid period here. And the scalar key here is the employee ID. So together with this employee ID and valid period, they become, the entity. This is the where we keep the primary key in a sense, like together, employee ID and this valid period. They are like together, and then we just see the salary value changing over time thanks to this kind of setup. Okay. Yeah. And then again, let's see how the exact syntax looks like. Just as a reminder, as I said, we need to use gist indexes here because gist already has this concept. Like it was making sure the underlying mechanism works for non-overlapping, and you instead of like you just create the extension extension, and then you can just do the temporal primary keys here. I wanted to give another example to make things a bit more stick. Imagine an availability bookings system, and I want to make sure that right one booking can only be done for one room for only one period. That's why I do just like room ID here and the create table bookings and during without overlaps, because I don't want this to be overlapping. I can't just overbook a room. And then let's try to insert. And so for the rooms, I insert two rooms, like blue room and green room. And for the blue room, the first room, I wanna insert like from let's say two things, two values, from 10 to 11 in the same day, and from 11 to 12 the same day again. And now if I try to insert like from 10:30 to 10:45, which will collide with the first period, I can't do that. So I see this purple output here. It's complaining that, hey, you can't do this. And now you could see how easy it was, right? It was just like adding this during without overlaps. And that's it. We did it. And this is also valid for the unique constraints, the same kind of syntax. Instead of primary key, you just do unique there, and that will work the same way for the uniqueness. Okay, and then if I want to, of course, insert an information for the room that doesn't have any booking, of course, it will allow it. And I can see that it worked. The first query I inserted for the 102, the other room. And then, since it is a new implementation, it currently doesn't accept empty values. So I wanted to show that with the second query. I tried to insert an empty range, and that didn't work. Okay, just to summarize now for the temporal, primary key, and the unique constraints, the clause is without overlaps. It could be for primary key and unique constraints. And if you remember what makes a temporal database chart, there was like uniqueness and primary key and referential integrity with foreign keys were required. So this all three needs to be working together to be able to check all those criteria. And as we said, instead of B3 indexes, we use GIS indexes here, and you have to create the extension. And if we didn't have this before, how people were doing this, working around with, again, with GIS, exclude using GIS. This is how we were doing, creating a constraint. And as you can see, like room ID width, so this is the scalar key, that is the same business key, and the ranges overlap. When you exclude it, it's kind of not overlapping, right? So they were like doing it this way before. Okay, and I want to show also to as the like to complete this part how it would look like for foreign keys, because normally, right, when we have a standard foreign key, what we know is like for every referencing row, there exists a reference row with the same key. So it's kind of equality based on the principle of an equality notion. So there's matching. But for the temporal, it's complicated, right? It's not like this easy. So for temporal data, model, it's like rows are valid for like over some time period, right? And so referential integrity also must hold during this period. So it is not a match for a single point. So it's periods containing periods. So that's why it's kind of a way of thinking differently. So here, the what I wrote here, like constraint bookings FK availability is like imagine if you had, let's say, bookings table again and room availability, and a booking is only valid for, let's say, some time range, and a room is only available during this range. You need to make sure these are referencing to each other. So uh, because if a booking depends on the room availability, you want to keep this relationship intact. That's why you need to have the bookings period during, it needs to be referencing, available period. That's what I added. So it's kind of different because in the primary key, we were adding without overlaps clause after the column. And here you are adding period during. So it's the order is different. But yeah, it's super simple syntax when you think about it. If you were doing this the other way around previously, it would be much more complicated than this is. Of course, there are like some limitations, like there are some on, update, delete, cascade, those kind of functions are not now supported yet, but I'm sure eventually it will be made. It's kind of harder, right? It's everything is much more harder than relational model here. Okay, and yeah, with this we finished the temporal topic for now. And as I said, like for Postgres, we had not valid supported for a very long time, but not enforced is something very new. So why we actually needed not valid even in the first end? Because when you if you can add a constraint as not valid, this skips the initial validation, but enforces the rule that we add going forward. And now Postgres 18 takes this further. Now you can declare a check, and foreign keys we will talk more later, as not enforced. So it will be never checked, but it will be still documented in the schema. So it is started with the check constraints. As you can see, you can just create the check constraint now and just add the not enforced clause at the end, and that will never be checked now. And PG constraint catalog got a new column, constraint enforced. It will show the status of it, so you can actually switch between enforced and not enforced. But you can't do this for check constraints now during the alter operation, so you have to drop and recreate the constraint. But I think the second slide, like the why we have not enforced, I think it would be more useful because for the foreign keys, when a foreign key is created, uh, uh, then there are some triggers also created, right? And so if you create something now with a non-enforced, that changes things. Since we are not checking or enforcing anything, then you don't need to create these triggers, right? You don't need to create these triggers. The checks are no longer required. And the constraint itself will be marked as not valid. And you can change this, right? So if you want to change some not enforced constraint to finally enforce, then this missing triggers will be created and the constraint will be changed to valid. So you need to know when you actually enforce something, there will be a validation scan that we were trying to avoid at first. So this is good for planning rollouts, so that you know when you can actually run these things, validations. But you need to be aware basically from the behavior how it looks like. And also, you can just take an enforced constraint and make it not enforced. That way, again, we are going back to the state of not enforced. That means that triggers will be dropped, and again, the constraints will be marked as not valid. But this is super because it gives you, lots of flexibility about how you want to plan this thing. And I think it's more important for foreign keys than the check constraints. Okay, there's another kind of relatively small change, I would say, comparing to this, temporary keys or not null and not enforced, the correlation issue. So uh, for Postgres, string comparisons, of course, depend on correlations, and non-deterministic correlations are kind of expected to create surprising results sometimes. So to prevent this going further, Postgres now requires either both primary and foreign key relationships use the deterministic correlations in both sides, or if they are using non-deterministic correlations, they need to use the same non-deterministic correlation on both sides. Why this is important? This might actually break when you do PG dump or PG upgrade, so you might need to do the schema changes first before you go and upgrade or do the PG dump and restore. Okay, and now we will come for the next group of changes. As I said, another big group of changes are not adding addition of not null constraints to PG constraint catalog. And now we have the, as you said in the table earlier, the con type n. And now you can just do list them in a table. So if you do \d plus, you could see all the constraints, and this it will include a section for the not null. It's a bit like noisy now, but maybe it could be optimized later on. And once you have a constraint instead of a flag, what you could do is like there are a lot of opportunities that is open now for not nulls as well. So you can name stuff, right? That's easy. Or you can drop the constraint, like just normal drop constraint. You can alter it. You can change the inheritance. Yeah, there's a lot you can do with it, and we will see some of the stuff in the examples as well here. Again, so once you have a proper constraint, it brings you to not valid. And we all understand, right? We are trying to avoid getting locks. We are trying to avoid getting, when you add a constraint with not null, you were getting, blocking rights. So if you don't want to block rights, how we were doing before this change, that we were adding a check constraint that does the not nullness, like, and then we were validating later on because every scan is different. So we are trying to lower the lock strength, let's say, and then we were setting not null after we actually worked through this. And now we don't need to do this. We can just say alter tablet constraint, edit as a like not null as not valid. And that's already really good. I think that's the most important thing you can do so that you have less impact on your system while you are creating the constraints. And yeah, so you can actually see this behavior with a new convalidated column. It is stored here, sorry. And the rest is pretty much the same. You don't need to worry about dumping and restoring. It behaves similarly. And inheritance, of course, once you have, again, a proper constraint style, you can actually allow the not null constraints inheritability. So you can just say, yeah, alter table alt constraint, set inherit or set no inherit. And if you want to have something like in no inherit to inherit, this is simple. It just adds the missing PG constraint entry for the children or the tables that are inheriting. But you can also do the other way around. If there's an inheritance, if you want to do the no inherit, you can do that too. In this case, what will happen? The connection between parent and child will be cut off, and the constraint in the child will not be touched. It will be only dropped from the parent, and the child tables will continue having this constraint as almost a local constraint. And yeah, basically from then on, from the parent, this will be not propagated for the new children, and the children who has this constraint can keep this constraint if they like to. Okay, and now we have some improvements on the partition tables that I want to add. This is the last part of our presentation. Uh, Allowing not valid foreign keys on partition table. So this feature was omitted when the foreign keys were implemented for partition tables. but has been requested, so now it's clear why it's useful, because now when you create this foreign keys, and if you allow it as like not valid on partition tables, you can actually do each partition validation independently. Of course, it will reduce the scope to that partition instead of blocking writes in everywhere, for example. So it needs to be able to avoid the locking for a whole table. Now you can just choose and do one by one validation. But if you want, of course, you can also still have the same behavior. You can run once on the parent table, and that will validate all the child foreign keys in one go. And of course, once you have the basically not valid, and you can also do the not enforced. Yeah, and that is also another thing, very small thing. We can drop only on partition tables. This was actually restricted because add only is not possible on a partition table. You can't have a constraint that's only for the parent. You need to have it for the children too. But symmetrically, this was taught kind of wrongly. Now you can actually do drop only on partition tables. And there are, of course, more changes coming to Postgres 19. If you want, you can check it. I'm putting here just for a reference later on when you see the presentation. I don't know if they will go into the Postgres 19 and what is the state, but yeah, the developments are still going on. And yeah, we reached the end of the presentation. Thank you for listening to me, and I hope you enjoyed the presentation. And let me know if you have any feedback and recommendations. I'll be around. Thanks.